Hi everybody. Here's another example of calculating the enthalpy of reaction using the standard enthalpies of formation of the reactants and products. And I've got those listed down on the lower left, but again, we would generally look those up in a table which we could find online or in a textbook or reference book. Okie doke, so the first thing to do is just organize ourselves, and we can assign each of those enthalpies of formation to one of our compounds. And remember that those are molar enthalpies of formation, so we'll multiply those by the coefficients of each compound. Remember that the standard enthalpy of formation of elements in their standard states is 0, so we just assign a 0 to that oxygen gas. We have 4 carbon dioxides and 6 waters, so we'll have to do some multiplication here before we're ready to calculate the standard enthalpy. Now I'll just multiply all those enthalpies out. And then the enthalpy of the reaction is just the sum of the standard enthalpies of formation of the products minus the sum of the standard enthalpies of formation of the reactants. That's a mouthful. The main thing you want to do here again is just keep track of the signs, and all these enthalpies are negative, so these signs really matter. So the first two numbers are minus 2952, and then we have to add that 169. And so the total delta H of the reaction is minus 2783 kilojoules. And one of the things we can do is just remember that this is the coefficient on ethane, which is kind of the subject of this reaction, is 2. So we might want to divide that by 2 to convert to a molar enthalpy. So if we do that, we get minus 1392 kilojoules per mole of ethane. And that usually makes more sense. You could also write that as something like minus 1.4 megajoules per mole. So that's quite an exothermic reaction.